We've looked at how we can model a stock index price process using geometric Brownian motion, but oftentimes our interest is in the returns process. Let's see how we can model that. If we assume that a stock price X follows a GBM process, then as we know, X at time t is log normally distributed. It follows that the returns process, which is the log of X of t divided by X of 0, the initial value, is normally distributed. What are the characteristics of that normal distribution? Well, the mean is simply our old friend t times mu minus sigma squared over 2. And the variance is simply t times sigma squared. Let's take a look at how the distribution of returns evolves over time. I'm looking at a GBM process with variable parameters. I'm setting sigma to 0.5, and we'll start with a value of mu of 0. And let's take a look at the distribution of returns as they evolve over time from t equal 1 through t equal 4. And as you can see, the mean of that distribution is moving to the left, it's moving downwards, becoming more negative over time. And the reason for that is simply with mu equals 0, then the mean of the returns distribution is t times minus sigma squared over 2. So it's a negative quantity. Now let's suppose we adjust mu, and we'll increase it to a value of around about 0.125. And you can see that at that level, the mean of the returns is constant through time. Of course, the variance in distribution is increasing as time progresses, but the mean remains constant at around 0. And the reason, once again, is that with mu set to around 0.125 and sigma set to 0.5, the mu minus sigma squared over 2 is approximately 0. So the mean of return remains constant at 0 through time. As mu increases further, we see that the mean of the returns distribution becomes increasingly positive. You can see the distribution shifting to the right. So, in other words, what's going on here? The state of a GBM process satisfies an Ito differential equation, dx of t equals mu xt dt plus sigma xt dwt, where wt follows a standard Wiener process. In other words, the returns process is described by a Wiener process with parameters mu minus sigma squared over 2 and standard deviation sigma.